happens when we boil water using an electric kettle? And why must we pay for that? That's what we look at in this movie about electric power and its cost. Before we start, make sure that you've subscribed to my channel and don't forget to hit the like button. Also, check out my website, www.learnscience.coza, for natural and physical science movies and quizzes, posters and workbooks, and also free competitions that you can join in on. Okay, so let's put some cold water into a kettle. The kettle has a heating element inside it. That heating element is a resistor. When we plug the kettle in and we switch it on, electricity flows through the heating element, and because it's a resistor, it resists the flow of electric current. The element makes it difficult for electricity to flow through it, and that causes an energy conversion to occur as the electric charges struggle to flow through the heating element. So electrical energy is converted to heat energy, and that heat energy goes into the water around the element, heating it up. And we have to pay for that energy because at the power station, it costs money for them to generate that electrical energy. The more electrical energy that we use in that way, the more we must pay. In a kettle or a stove or an oven, we use that electrical energy to convert it to heat energy. In a fan, we use electrical energy by converting it into kinetic movement energy. And in a light bulb, we use electrical energy by converting it into light energy. Whatever device we use and whatever form of energy that device converts electrical energy into, we need to pay for the electrical energy that we use. The amount of electrical energy that we use is called our energy consumption. Energy is often measured in joules, J, but it's usually more convenient to measure electrical energy consumption in kilowatt hours rather than in joules. To understand this, we need to understand electrical power. Let's say we have two kettles, and we put 1 liter of water into each. We use water which has the same starting temperature in both cases, maybe 20 degrees Celsius. We switch both the kettles on. Kettle A boils after 1 minute and kettle B boils after 2 minutes. Let's say they boil at 100 degrees Celsius. First question, in which case is our energy consumption more, A or B or both the same, and why do you say that? We pay for energy consumption, so which one should we pay more for, A or B or both the same? Can you see that both kettles need to heat the same amount of water up, 1 liter, from the same starting temperature, 20 degrees Celsius, to the same ending temperature, 100 degrees Celsius? So can you see that they will both have to convert the same amount of electrical energy to heat energy because they're both doing the same job? So you should have to pay the same amount in both cases. Second question, which kettle would you prefer to have? If you're in a hurry, you'll definitely prefer to have kettle A because it does the job of boiling the water quicker than kettle B. Now, let's say that you go to the shop and you want to be sure that you buy a quick kettle like A. How do you know which one to choose? You need to look for the power rating of the kettle. You'll always find the power rating in watts or kilowatts on the box, and also on the appliance itself. Let's say A has a power rating of 2000 watts, which is 2 kilowatts, while B has a power rating of only 1000 watts, 1 kilowatt. What does that mean? Power is the rate at which energy is converted. How much energy per time? Remember that energy can be measured in joules. Time can be measured in seconds, and power can be measured in joules per second, which is also called watts for short. 1 joule per second equals 1 watt. So a kettle with a power rating of 2,000 watts converts 2,000 joules of electrical energy into heat energy every second, whereas a kettle with a power rating of 1,000 watts converts half of that, only 1,000 joules of electrical energy into heat energy every second. And that's why we have to wait longer for kettle B to do the job. We've seen that power equals energy divided by time. So energy equals power multiplied by time. Let's work out how much electrical energy kettles A and B converted into heat energy while they boiled the water. Kettle A. Energy equals power times time equals 2,000 watts, which is 2,000 joule per second, multiplied by 1 minute, which is 60 seconds. Notice that if we give power in the unit joules per second and time in the unit seconds, then seconds cancel, and we're left with joules, which is the unit of energy. 2,000 times 60 equals 120,000 joules. Kettle B. Energy equals power times time equals 1,000 watt, which is 1,000 joule per second, multiplied by 2 minutes, which is 120 seconds. 120,000 joules. As we discussed before, they do the same job, so they must be converting the same amount of electrical energy to heat energy, which, as we see, they do. So, you will pay the same amount in both cases, but how much will you have to pay? Let's say you live in South Africa and the cost of electricity is 0.9 rand per kilowatt hour. How do we use that information to help us work out how much we have to pay for these 120,000 joules of energy that we use to boil our kettle? To make it easier, let's do the calculation of the energy consumption of the kettles again. But this time, let's use the units kilowatts and hours rather than joules and seconds. Energy equals power times time. For kettle A equals 2,000 watts, which is 2 kilowatts, multiplied by 1 minute, which is 1/60th of an hour. So that's 2 kilowatts times 1/60th of an hour equals 0.033 kilowatt hours, which is the same amount of energy as 120,000 joules, just expressed in a different form. Let's check the calculation for kettle B. Energy equals power times time equals 1,000 watts, which is 1 kilowatt, multiplied by 2 minutes, which is 2 over 60 hours. So it's 1 kilowatt times 2 over 60 hours equals 0.033 kilowatt hours. So back to the question of how much this will cost. Let's say our unit cost of electricity is 90 cents per kilowatt hour. That means that we have to pay 0.9 rand every time we use 1 kilowatt hour of electrical energy. So can you see how to calculate how much we have to pay for using 0.033 kilowatt hours of electrical energy? Will it be more or less than 90 cents? 0.033 kilowatt hours is less than 1 kilowatt hour, so we're going to have to pay less than 90 cents. Can you see how to work out how much we'll have to pay? Pause the movie to figure this out yourself before I show you. Cost equals energy consumption in kilowatt hour times unit price of electricity in rands per kilowatt hour. So that equals 0.033 kilowatt hour times 0.9 rand per kilowatt hour. Notice how the energy unit kilowatt hour cancels out and we're left with a cost unit rands. 0.033 times 0.9 equals 0.03 rands. 3 cents. So, in summary, we've seen that we pay for how much energy an electrical appliance converts from electrical into the form of energy that we need. The cost per unit of electrical energy is given in the currency, for example rands, per kilowatt hour. The cost equals your energy consumption in kilowatt hour times the unit price of electricity in, for example, rands per kilowatt hour. How do you work out your energy consumption in kilowatt hour? You look at the power rating on your device. The power of the device is the rate at which that device converts energy. If that's given in watts, convert it to kilowatts by dividing by 1,000. And then you need to know for how much time you use that device in hours. If you know the time in minutes, divide by 60 to convert to hours. Energy consumption in kilowatt hour equals power in kilowatt multiplied by the time you use that device in hours.